Hello, my angels. So here is a solution key for this week's homework. I'll also email this out as a PDF. So number one, the momentum of an object depends on the objects, and then it says pick two quantities. Momentum is mass. Let's do this in red, so just the color is different. It's mass times velocity. Hopefully that was pretty straightforward. Please notice you do have this equation on your formula sheet, P equals mv. You'll notice this unit, there's really sort of only two equations. There's P equals mv, and then there's one longer, complicated 3-in-1 equation. We'll spend a couple of days looking at that. But momentum is mass times velocity. Number two, momentum is momentum is definitely a vector quantity. It is most definitely a vector quantity. Why does that make a big difference? Well, momentum is really good for momentum is good when you're analyzing objects that aren't curving or changing their direction like crazy. So as an example, using momentum to analyze a roller coaster where you have the hill changing its angle of steepness would be very, very difficult. And so for roller coasters, we typically use work and energy, which are scalars, to analyze them. But where momentum really shines is in collisions. Number three, which of the following are complete correct descriptions of momentum? So momentum is a vector, which means A is no good right away, no direction, much like your future. Sorry, I didn't say that, please. And then we check the units. B is good, kilogram meters per second. C, kilogram meters per second squared. No. That would be mass times acceleration. Ooh, that's a force. C would be a force. D, that's a velocity. E, I'm good with that. F has the right units, but it's missing its direction. Number four, the two quantities needed to calculate an object's momentum are, you know what, let's copy both of these questions at once, Mr. Dueck, 4 and 5. So the two quantities needed to calculate an object's momentum are the object's mass and the object's velocity. If you just want the magnitude, mass and speed will work. Remember, speed is a scalar, 12 meters per second. Velocity is a vector. It would be good if there was an easy way to remember that speed is a scalar and that velocity is a vector. I got nothing. You'll have to come up with something on your own. Velocity is a vector, 12 meters per second north. Or what we typically have done, rather than using north, south, east, and west, we've used up for positive, down for negative. We've used negative for backwards or left, and we've used positive for forwards or right. And we'll continue that convention this unit. In a few days, in a few lessons, we'll be having changes of direction. Number 5, consider the mass and velocity of object A and B. So object A has a momentum magnitude of 16 kilogram meters per second. Object B has a magnitude of 8 kilogram meters per second, mass times velocity. I don't know about the direction, but the magnitude is all this question is asking about. So it looks like object A has 2 times the momentum. Number 6. Let's do 6 and 7. I think I can fit these without needing extra room. So number 6 says calculate the momentum of a 2 kilogram brick moving through the air. So momentum is mass times velocity. You'll notice I'm paying a lot more attention to the vector notation. I'm bringing back the vector arrows. I won't take marks off if you don't put the vector arrows on in your work, but you might lose some sloppy marks because you might forget that you're dealing with vectors. That's some foreshadowing for our next lesson. For now, this is going to be 2 times 12. I can do that in my head. 24 kilogram meters per second. Direction west. B, momentum is mass times velocity. It's going to be 3.5 times 1.2. 3.5 times 1.2. Do that one in your head, Mr. Okay, fine. 3.5 times 1 is 3.5. 3.5 times 0.2 would be 0.7. So it's going to be 3.5 plus 0.7. Is it 4.2? Did I get the magnitude right? Hey, good. 4.2 kilogram meters per second. And the direction would be south. Number 7. With what velocity must a 0.53 kilogram softball be moving to equal the momentum of a 0.31 kilogram baseball? Okay. Well, I'm going to do the baseball here. I'm going to do the softball here. They want me to find the momentum of the softball, which is going to be mass times velocity. Well, they want me to find the velocity, actually. I said the momentum. That's going to be the momentum divided by the mass. Now, they did give me the mass of the softball. It's, sorry about that, 0.53. What I don't know is the momentum of the softball. Wait a minute. They told me that the baseball has a mass of 0.31 and it's moving at 21. Mr. Dueck, I thought you said the mass of a baseball was around 0.15 or 0.14 grams earlier in the lesson. For this question, I was just making up some numbers, but you're right. I don't think the mass of the baseball is accurate. So the momentum that the baseball has is 0.31 times 21. It has 6.51 kilogram meters per second. So I can put that right there. If I go answer button divided by 0.53, the softball needs to be moving at 12.28 or 12.3 meters per second. Really, by the way, I didn't find the velocity. I only found the magnitude. I didn't give you a direction, so that's sloppy writing on my part. Really, what I should say is, what is the magnitude of the velocity? But whatever. I'll fix that for next year. 8, 9, and 10. Well, let's do 8 and 9 first. Number 8, calculate momentum of a 1.6 times 10 to the 3 kilogram car traveling west at 20 meters per second. Okay. Momentum is mass times velocity. It's going to be 1.6 times 10 to the 3. I wrote that messy. Let's try that again. 1.6 times 10 to the 3. 20. Oh, I can do that in my head. It's going to be 3.2 times 10 to the 3, or 32,000. kilogram meters per second. Direction, same as the velocity, west. What about the truck? Well, this 110 kilometers per hour, I need to convert. How do I convert kilometers per hour to meters per second? I divide by 3.6. You know what? I'm so lazy. I'm going to do that all in one step. I'm going to say that momentum is mass times velocity. The mass is 2.5 times 10 to the 3. The velocity is 110 divided by 3.6. I could have done that on a separate line, but why bother? 2.5, scientific notation button 3. Oh, scientific notation button didn't go. Scientific notation button 3 times 110 divided by 3.6. And I get a magnitude of 76,400 kilogram meters per second. And the direction would be the same as the velocity, north. Number 10. How fast? Oop, wrong button. So I don't remember if I said it in the lesson. I should have. I should have said something like, how many variables does the momentum equation have? And you would have said 3, a p, an m, and a v. So how many different ways is there to write this equation? 3 different ways to write this equation. So if I want me to get the v by itself, I guess I would move the m over. How would I move the m over? Let's see, if momentum is mass times velocity, I guess velocity is momentum divided by mass. So the momentum is 4.50 divided by 1.5. I can do that in my head. I'm pretty sure it's going to be 3.0. Hey, I was right. Meters per second. Direction, same as the momentum, east. So as far as I'm concerned, I can give you any two of these and you can find the third. This gives us another way to find velocity, by the way. So we already had, what was it, VF equals VI plus AT, and VF squared equals VI squared plus 2AD, and D equals bracket VI plus VF close bracket over 2 times T. We had all those different ways. Here's yet another one. And again, when in doubt, use the DFIC approach. List your data, and that will probably twig your brain as to which approach you're going to be using. Number 11. Calculate the magnitude of this ball's momentum. Okay. Ooh, yucky units is what I see. Well, first of all, what I see is that's not where I wanted this to go. Let's go right there. Okay. Really, this is just a review of some unit conversion. I mean, I know that momentum is mass times velocity. The mass here is 75 grams. How do I convert that to kilograms? Well, I know there's 1,000 grams in 1 kilogram. I know it's divided by 1,000, but if you've blanked out, you can build a chain. You can say, I want grams to cancel. I want kilograms to be left behind. And kilo is 10 to the third, or 1,000. Remember, the 10 to the always goes where the metric prefix isn't. So it's going to be 75 divided by 1,000, divided by 10 to the third, because the 10 to the third is on the bottom. And I get a mass of 0.075 kilograms. The speed is yucky as well. This speed is in centimeters per second. I want meters per second. So I want centimeters to cancel, I want meters to be left behind. So centimeters is going to go on the bottom, so it cancels out the other centimeters. Meters is on the top. My units cancel. Oh, but centi is 10 to the negative 2. The 10 to the always goes next to the base unit where the metric prefix isn't. So since the C is on the bottom, the 10 to the goes on the top. So I end up with 57 times 10 to the negative 2. That's it, divided by, times 10 to the negative 2. And I get 0.57 meters per second. Now, this is plug and chug. Momentum is going to be 0.075 times 0.57. Not a very big momentum. If you got hit by this ball, you'd be able to shrug it off pretty easily. And I get 0.04275. If I go to 2 sig figs, 0.43 kilogram meters per second. Number 12. Oh, a little too far. That'll work. Okay, they want me to find the momentum. I know that momentum is mass times velocity. So the first thing that I would have done is I would have said, hey, easy peasy. Momentum is mass times velocity. And then I would have said, okay, there's an acceleration. They want the momentum after the acceleration. I think this is going to be mass times v final. And I'm going to have to figure out v final. V initial is 6. A is 2. T is 1.5. I can use VF equals VI plus AT. I can go 6 plus 2 times 1.5, which I'm pretty sure is 9. And I can plug that in over to here, and I'll get momentum is mass 5 times V final 9. It's going to be 45 kilogram meters per second. Direction. Oh, you know what? This should really say the magnitude, or did I say calculate the magnitude of the ball's momentum? Maybe I did. No, calculate the ball's momentum. Should say calculate the magnitude of the ball's momentum in number 12. I'll change that for next year because I didn't include a direction. Number 13. Rock is dropped from the top of a 30-meter high building. Calculate the ball's momentum when it strikes the ground. Mr. Dueck, is it 0? No, your final velocity when you hit the ground is not 0. If you don't believe me, do a belly flop onto the concrete sidewalk. I assure you it will hurt. If your final velocity was 0 when you hit the ground, it wouldn't hurt. Your velocity after impact, after the ground decelerates you, will be 0, but that's not what we're talking about here. So my first thought was, again, to go momentum equals mass times velocity. And again, I came to a screeching halt. I said, you know what? Even though this is technically asking me to find the momentum, I'm going to spend most of my time finding velocity. Well, dropped. VI is 0. I'm in free fall, so I know that A is negative 9.8. D is, it's a displacement. D is negative 30, because I'm starting on the top of the building, I'm ending up below from where I started. So I can use VF squared equals VI squared plus 2AD to figure out V final. Although, since VI is 0, I could just do that. How'd I get rid of a squared? Square root. VF is going to be the square root of 2 times negative 9.8 times negative 30. That 9.8 is messy. Still messy. Jeez. Hey, it's not that easy to write on this tablet screen. So, two times negative 9.8 times negative 30. Oh, not minus 30, negative 30, Mr. Dueck. Square root of 588. I get 24.2487. Since this is not my final answer, I'm going to resist rounding off. I'll use my answer button. So I'll write 24.2. Although this is technically wrong. I have to add the negative myself, because when I hit the square root button, my calculator will always assume that I want the positive value, but in this case, I definitely want the negative value, because we're going down. Okay, here we go. Momentum is mass times negative 24.2. I'll write 24.2, but I'm going to use my answer button. So it's going to be 2 times answer button, and I get 48.5. Is that the correct answer? It is. So the magnitude is 48.5 kilogram meters per second. And then you could say as a direction down, or if I use this negative, I would have a negative there. Just don't say negative and down at the same time, because technically I think negative down is actually up. Last one. Woohoo! Mr. Dueck, is this stuff going to get tougher? Yeah. This is going to get more challenging. This was just dipping our toe into the shallow end of the momentum pool. But it's also pretty cool. Collisions and explosions. Number 14. Gotta get my cursor back. There we go. Calculate the rock's momentum as it strikes the ground. Okay. Well, again, I said momentum is mass times velocity. And I said, you know what? I need to find the velocity when we hit the ground. I need to find V final. I chose to start at the top. So I chose to say this. At the top, VI is 0 for a split second. A is still negative 9.8. And from the top down, we fell 7 meters. So I said D is negative 7. That allowed me again to use VF squared equals VI squared plus 2AD. It allowed me to go VF equals the square root of 2AD. It allowed me to go VF equals the square root of 2 times negative 9.8 times negative 7. 2 times negative 9.8 times negative 7 square root. I got 11.7. Again, this is negative or down, so I said negative 11.7 meters per second. And again, I'm going to use my answer button. But now I can get my final answer. The momentum is 1.5 times negative 11.7 the momentum equals 1.5 times answer button, and I get 17.6 kilogram meters per second down, or you could call that negative. So if you can try and get this done for Friday, if you have any questions, if there's still something you don't understand, send me an email and we'll set up a little Zoom mini conference or something like that. I don't mind if you're not free during the days. I can get together with you for some tutoring in the evenings. Can also help you with your math homework if you want to, or if you have any other questions. All right. Again, I miss teaching all of you. Take care, my angels.